Welcome to 46th lecture. We are studying circuit analysis, and today we'll start studying average or mean value of sinusoids. Sinusoids is a class of signals where we have sine signals and cosine signals. Collectively we call them sinusoids, and these are most widely used signals in AC circuits. Therefore, we are interested in finding their average or mean value. Why do we compute average or mean value of a signal? Because almost all AC signals are varying with time. F of t is a signal that varies with time. We want to find out the average or mean value of this time varying signal. So today we see that for a periodic signal, a signal is periodic if it repeats itself after finite time. For example, a sine signal, a cosine signal, they repeat themselves after finite time. Therefore, they are periodic signals. A periodic signal has a time period that is less than infinity. They repeat themselves oftenly. For a periodic function f of t, its average value f average is computed. First we divide by the time period. Suppose it's a periodic signal and it repeats itself after time capital T, the time period. We divide it by that number and then we integrate from 0 to its time period, the signal f of t. Right. So to better understand this concept of dividing by time period and integrating, let's solve an example. V of t is V sine omega t plus theta. It's a signal. It's a sine wave that keeps on repeating itself from minus infinity till infinity. Let's start viewing it from time t is equal to 0. We have t here and this signal b of t plotted on y-axis. What is the time period of this signal? We know that this omega we have already studied. It is equal to 2 pi the frequency, and we already know that frequency is 1 over t. So t, the time period, would be 2 pi over omega. So for this sine wave, the time period, the time after which the signal repeats itself, its time period is 2 pi over omega. If omega is 1, it is 2 pi. So now we have computed the capital T of this signal, and we know its value. So now we are ready to find V average. V average is 1 over the time period. Time period is 2 pi over omega for this signal. Integrated from 0 to time period 2 pi over omega sine omega t plus theta dt. plus theta dt. Let's solve it. It's straightforward. From elementary school, we know that sine of omega t has an integral minus cos omega t minus cosecant of omega t plus theta divided by omega. So, and we put a limit from 0 to 2 pi over omega here. So this omega cancels with this omega, and this is 1 over 2 pi. Let's put the limit. Let's write this negative sign outside of these brackets. Cosecant of omega times, put this value of t, 2 pi over omega plus theta minus cosecant of, put this value of t is 0 plus theta. So V average is 1 over 2 pi cosecant of 2 pi plus theta minus cosecant of theta. Right. Let's see what this value is for different values of theta. Cos of omega t can be plotted as a signal having a value 1 at time t is equal to 0, -1 at in the middle, and at the end of this time period it's also a 1. So if it is cos of t, cos of 2 pi, this is pi, this is 2 pi. This is cos of 2 pi. Cos of 2 pi is a 1. Cos of 2 pi plus theta. Suppose if we put as an example theta is equal to 0 degrees. So V average is 1 over 2 pi cos of 2 pi plus 0, which is cosecant of 2 pi minus cosecant of 0, and we know 1 over 2 pi cosecant of 2 pi is a 1. This is a signal with omega is equal to 1. 1 minus cosecant of 0 is also a 1. So 1 minus 1 is a 0. So we have shown that for theta is equal to 0 degrees, V average of a sinusoidal signal is 0. But we claim that this expression V average is equal to this is true. So now we are going to make a claim that this expression is true. So our claim that this expression V average is equal to 1 over 2 pi cosecant of 2 pi plus theta minus cosecant of theta is true for all values, for all possible values of theta. You are required to verify it as a homework. Try different values of theta, maybe for 10 degrees. Put 10 degrees here, 10 degrees here. Your answer should be 0. Put 20 degrees, maybe 30 degrees. So since theta is the phase shift, it can be any value from 0 to 360 degrees. So put any value of your choice and your answer should be 0. So this is your homework 1. At the end of this lecture you have 2 homeworks. Homework 2 is that you are required to prove that V average for V cosecant omega plus theta is 0. So you have to verify that V average of cosecant signal is also 0. In this lecture we have proved that average value of sinusoidal signal average value of sine is 0. So you have to verify that average value of cosecant is also 0. In next lecture we will study some more important quantities about AC signals. Thank you.